Hello. Today we're going to talk about Chapter 10, Understanding Randomness. Okay, so hopefully you enjoy this little comic. All right, we see randomness when we play games. All right, that's where it starts, okay? We don't want to play a game unless it's random, right? We want to feel that, we can't predict who can win. And usually the set of outcomes are equally likely, all right? But of course, games can get a lot more complicated, especially when you start adding a deck of cards, okay? So hopefully you recognize what a deck of cards is. If not, you really need to memorize this, okay? Because they like to throw questions and examples that have to do with, what are the chances of getting a queen or odds of getting a three of diamonds, things like that. So because there's all this variability in a deck of cards, that's why usually games aren't always equal chance. Okay? All right, so back to randomness. True randomness is really hard to get, okay? People are inherently biased, okay? There was an example in the book, if I asked you all to say, what's your, pick a number between 1 through 4, it is not going to be evenly spread out, okay? Trials have shown that humans, can be predictable, okay? And people picking a 1 versus a 4 is different. All right, so computers like your graphing calculator and websites that can just spit out quote unquote random numbers aren't necessarily random because there's a program that controls it. Okay, so even they, have a hidden agenda kind of thing. Okay, so this is like a random number table. Okay, they can be super long. You can see that at the end of your textbook. Well, if you had a real one. All right, so we use them, and usually these pseudo-random numbers are good enough. Okay, they're random enough that we can use them for simulations. Okay, so we simulate reality by imitating that process. Okay, so we manipulate it and control it with this random programs. Okay, so how do we do a simulation? Okay, so this is the nitty-gritty of what a simulation is. So the sequence of events we want to investigate is called a trial. Okay, what we want to happen, what we're looking for. All right, a specific part of our simulation is called a component. So a building block would be like one piece. So like drawing a card. Okay, the sequence of event would be drawing multiple cards until I get an ace. Okay, so after we do a certain number of trials, okay, certain number of components over and over and over again, we record what happened, and that's our response variable. And then we usually want to do 7 steps when recording a simulation. Okay, so these are the 7 things you want to do when you are running a simulation. You want to cover this in your description. Okay, so let's do it. The best way to do anything is with an example, right? So let's do this. All right, I like the Nascar problem because I got some cousins that are huge Nascar fans. They live in Daytona, and they really want to collect all those collectible playing cards found in those cereal boxes. Okay, we know that the relative frequency of the cards, 20% goes to LeBron, 30% of the boxes are Danica, and 50% of the boxes have Dustin's card in it. Okay, we want to simulate it using the random number generator to determine how many boxes it's going to take me to get all 3 cards. Okay, so these are our possible random numbers. Okay, possible digits. Okay, I want 20% of them to be LeBron, so 0 and 1, 30% to be Danica, so 2, 3, and 4, and 50% to be Dustin. So every time I get a 0 or 1, that's like getting a cereal box with a LeBron card in it. Pulling a 2, 3, or 4 is like getting a cereal box with Danica's card in it. 5, 6, 7, 8 is a cereal box with Dustin's card in it. Okay? So we go down the line. So this first random generator says we get an 8. Well, an 8 is Dustin. Then a 9 is Dustin. A 0 is LeBron. 6 is Dustin. 4 is Danica. Okay? So here I went ahead and highlighted whether or not it was LeBron, Danica, or Dustin. So in my first trial, my first simulation, okay, I would go, well, I'd have to pick the first box. I just have Dustin. Now I have LeBron, so that's a new one. All right, now I need a green one. Don't have a green one. Now I have a green one. This took me 5 boxes to get all 3. Okay, so now I stop. That's my first trial. So trial 1. Trial number 2. I got a green one, a blue one. Don't care about getting an extra green one. Now I have a red one. So in trial 2, it took me 4 boxes. The next one, blue, blue, green, blue, 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 red. Trial number 3 took me, what was that, 7 boxes. Okay, hopefully you're starting to see the pattern, and we can keep going down through all of these. Okay, that's what we're trying to do. That's our simulation. So let's write it up. Okay, so how would you tell the FRQ, how would you tell the AP reader what you're doing when you're building this simulation? Okay, this is how you'd write it. Our component is the opening of a box of cereal, just opening one box. The digits from 0 to 9 are equally likely to occur. So 20% will use two of those two digits, 2 of the 10 digits, so 0 and 1. Okay, see how I'm explaining it? We pretend to open boxes, so repeat the components, opening a box of cereal, until our collection is complete. We get all 3. We do this by looking at each random digit and indicating what picture it represents. We continue until we found all 3. We want to find out the number of boxes it might take to get all 3 pictures. All right, pay attention to how I wrote it all out. That's what I'm looking for. Okay, don't just assume I know things because this is AP statistics. All right, you're trying to get the information out into the world. So if you can't explain this to a 5-year-old, okay, well, maybe like a 10-year-old, so I have a little understanding of digits, okay, then you're not explaining it well enough, okay? Don't just assume I know what you're doing with the random number generator, okay? So sometimes it helps to have a chart, okay? So I listed them out. So my trial 1, remember the first one we did was 89064. I know they use different colors than me, I'm sorry. All right, trial 2 took 4 boxes, trial 3 took 7, right? We kept going, and we ran 10 trials. 10 trials, and it took this many boxes to get all of the ones we wanted, okay? And then I did a frequency plot, okay? All right, so you collect and summarize the results of all your trials. You know how, okay? Shape, center, spread, all that good stuff. So depending on what the question is, you may want to include more. All right, so based on our simulation, we estimate that the customers hoping to complete their card collection will need to open a median of 5 boxes, right? Because the data is skewed to the right, we're going to use the median, which is 5. Assume it'll take 5 boxes to get all 3. All right, if you fear that these may not be accurate estimates because we ran only 9 trials, you are absolutely correct. The more trials, the better, and 9 is woefully inadequate, okay? We need a lot of trials, but for me just describing it to you and us just going through the examples, I'm only going to do 10, okay? But in your homework, you're going to want to use at least about 20 trials. Okay, but if you're actually conducting a study, you would do even more. Okay, the more, the better. All right. So let's do another example before I start explaining how many trials. Okay, so let's do we'll just do our little bit of trials. So, dorm lottery scandal. All right, 57 students wanted to get a desirable dorm room, right? A triple. So 3 kids, a fireplace, and a private bath. This sounds like disaster, right? No college student needs a fireplace. Hopefully it doesn't work. All right. Anyway, so 20 of the participants were members of the same varsity team. Okay? So that's not even half. So you have 57 total. 20 of them are from the varsity team. Okay? When all 3 winners were members of the team, the other students cried foul, right? The other students cried like little babies, right? They said, that can't be right. There's no way all 3 can come from the varsity team. Someone cheated, okay? So let's actually see if that's true, right? How do we decide? Well, we can run a simulation, okay? That's what we can do. Run it a whole bunch of times and see how likely it is to pick 3 people from a varsity team. Okay, so let's do the simulation. This is what I would do. So we want to see if it's unlikely that all 3 varsity athletes would get that great room. A component is the selection of 1 student. So we're going to look at 2-digit random numbers. We'll let 0 to 19. Notice that started with 0 and not 1. That's 20 kids. Represents the 20 varsity applicants. I can't tell you how many times I have to take off points because people say 0, 0 to 20. Nope, that's 21 kids. Okay, start from 0 and you go to 19. That's 20 varsity applicants. Okay, if you want to go from 1 to 20, then that's fine. Just put that. Then 20 to 56 would represent the other 37 applicants. That's 37 numbers right there, okay, because you're including the 20. All right, we're going to skip numbers 57 through 99 because those kids don't exist, right? I only had 57 kids want to participate. So if I have 57 kids participate, then I need 43 numbers to be trashed. Okay, so we just skip them. Okay, we can do that with a random number generator, right? Because it's not always going to be that easy, 20%, 30%, 50%, like in the cereal box problem. All right, so each trial consists of identifying parts of digits as varsity or non-varsity until 3 people are chosen. Okay, so ignoring the out of range or repeated numbers because you can't pick Abby twice. Okay. All right. I can't put that just said that. So then the response variable is whether or not all 3 selected students are on the same varsity team. That's what we're looking for. We want all 3 to be on the same team. So we run a trial. So 74 thrown out. Second person, varsity. 94 thrown out. 39, not a varsity. 02, we already picked them. 77 thrown out. 55, non-varsity. Non-varsity. Okay, so I had 3, well, here I had a varsity, but then I had a no and a no. So they were not all varsity. 1 varsity, 2 no's. 1 varsity, 2 no's. Right? You're starting to see that the only one with 3 varsities is number 6, trial number 6. So out of 10 trials, only 1 of them produced all varsity. All right? So that means 10% of my trials showed that varsity team member would be picked. Okay? Now, it's not particularly likely, right? You know, if you said it was 10% chance of rain, you're like, oh, it's not likely to rain, but it's still a possibility, okay? What I really need to do is do more trials, okay? A smaller frequency of all the varsity, yeah, I want a smaller percentage to actually accuse them of unfairness. Okay, now what's the right percentage? There is no, right? Just like with every stat problem, it's all about interpretation. So really think about it, you know, in context. Dorm lottery, 10% of the trials will be varsity kids. Yeah, I would do more trials to be certain with that, because that seems like it could be by chance, albeit unlikely. Okay, I know, it's stat man, it's the words. Okay, so how do you pick random integers with your graphing calculator? All right, so where do you find the random integer? You go to math, go all the way over to probability, and go to number 5, random int, random integer, and you're picking a random integer. Oh, sorry, they already put the parenthesis. From 0, the comma's right here, 1, and then end it. So that's like a coin toss. So you could say 1 is heads, 0 is tails. So you get heads, tails, 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 heads, tails, right? So that's, instead of actually flipping a coin, you could just use your calculator, right? All right, then you could do 1, 6, so that's like rolling a dice. So instead of rolling dice and having it go all over the place or be loud, right? You can just use your calculator. Random integer, just to show you this, how this works. For number, if you want to do 2 dice, okay. So you want to roll one number, you want to pick one number from 1 to 6, or I'm sorry, 2 numbers from 1 to 6. That's what you want to do. That's your range, from 0 to 1, 1 to 6. So here we rolled 2 dice and got 1 and 4. Rolled another dice, 6, 6. Rolled it again, 2s, 1s, that's crazy. 5 and 1, there we go. 3 and 2, right? Random is always randomly weird. Okay, we could also do it for our cereal boxes, our dorm lottery, right? We could do that differently using our calculator as opposed to a random integer list. Okay, just showing you different options. Okay, so what if we don't simulate enough trials? Okay, how do we test it? How do we know if we've done enough? All right, well, one way we can kind of say how many is enough is just pretend we're focusing on LeBron James from our cereal box. Okay, remember he was supposed to be in 20% of our boxes. Okay, so let's just focus on 10 trials with just getting LeBron. Okay, so the first box, I didn't get LeBron. Second box, no. Third box, my random digit, no. My fourth box, yes. Sixth box, yes. 10th box, yes. So, all right, notice I'm adding up my likelihood of getting LeBron out of all the boxes. So 0 out of 1, 0 out of 2, 0 out of 3, until I had the fourth box, 1 out of 4, I got him. So out of 10 trials, I only got to about 30%. But keep in mind, I'm supposed to be around 20%. Okay? He's supposed to be in 20% of the boxes. So the more boxes I pull out, I want to get closer to that 20%. So for the homework, we suggested 20 trials. Let's see, let's go to 20. We go to 20 trials, we're all the way over here. All right, so 20% gets us a little closer. I'm sorry, not 20%. 20 trials gets us to around 25%, whereas 10 trials, we would estimate LeBron was around 30% of the boxes. Let me say that again. So after 10 trials, we would expect LeBron to be in 30% of our boxes, right? Right? Because simulation is supposed to tell us what we don't know. So pretend we don't know this. Okay, pretend that we don't know that he's in 20%. Well, in 10 trials, it only shows 30%. In number 2, it shows 25%. That's still not where we should be. So let's go big. Let's use a computer. Let's use 1,000 trials. What happens, okay, as I go on? Well, notice that's just a little over 20%. So if we ran a whole bunch of problems, well then yeah, we would say LeBron's in a little over 20%. Okay? So that's even the best, okay, is to use 1,000 trials, because notice that is the closest to 20%. Okay, so the more trials, the better. We did 10 and 20 in here because I'm showing you how to do it, right? We're doing a few examples, right? Doing it by hand. All right, things to notice. All right, things you don't want to do wrong. Don't overstate your case. All right, a simulation is always wrong. Okay, it's not the real thing. It's never going to actually produce the perfect real world example, right? This one, we knew that the cereal boxes had 20%, but our simulation didn't exactly show that. Okay, so there's always going to be a little bit of error. Okay, so you want to model your outcome chances accurately. Okay, so don't construct a bad simulation. All right, so for instance, some people might say, okay, I'm going to do a random number generator or use a random number table, and 0 will be getting 0 varsity members. This is for the room drawing. All right, 1, if I get a 1, that means I get 1 varsity member. 2, I get 2 varsity members. 3, I get 3 varsity members picked. Okay, and then I can just ignore the other digits. Okay, or use a calculator just to get 0 through 3. Well, why is that wrong? Because each of these have an equal likelihood of happening. So that's saying that if I get a room of 3 team members, that's going to happen 25% of the time. That's not likely. That's not what we showed in our simulation. Okay, that's incorrect because I have more you don't know what you're doing when you're picking those kids, like what the chances of getting all varsity members. That's what you're looking for. So just going ahead and assigning them, you're already assigning that percentage. Okay, so watch how you do your simulations. Okay, because this would be incorrect. All right, and always run enough trials, right? Simulation is cheap and fairly easy to do, right? Just kick it out of the computer, okay? It'll make it precise, or we'll figure out exactly how many trials later. Okay, so we'll get there. All right, hopefully this makes sense. You know where to find me.